Good morning, good afternoon, and good evening, everyone, and welcome and thank you for joining Acentury's webinar, PIM Research Discovery in 5G in-building systems. My name is David. I am the moderator for today's session. Just a couple of housekeeping items before we get started. This will be a fully muted webinar session. If you do have questions, however, you can use the Q&A icon button at the bottom of the Zoom application window. One of our panelists will attempt to answer them, and if they can't, there is a designated Q&A session at the end of the seminar, and hopefully we will have time to address it. Today's agenda, I will start with an introduction to the company, Acentury, as well as I will provide an introduction to today's presenter, Fan Zhang. I will then hand off to Fan, who will talk about the latest trends in building solutions, and he will complete the webinar with section 3, providing his insight on a research study and how that applies to potential PIM issues in 5G systems. So firstly, an introduction on Acentury. Acentury is a RF and engineering company founded in 2011 and specializes in test and measurement solutions. We serve several customer verticals, including carriers and operators, device manufacturers, network equipment manufacturers, and cable MSOs, to name a few. Since 2013, we've focused on product development and have been launching products into the global wireless communications industry, starting with RADIOCOMM, a low PIM passive networks components hardware line, and more recently, a software dedication with Lanta, a turnkey solution that allows lab admins to remotely manage and automate their wireless lab operations. Omera, a cloud-based orchestration platform to automate and scale next-gen radio access deployment. And rounding out the portfolio is SimMatrix. This is a completely separate company subsidiary of Acentury. It is a filter design and test and measurement platform featuring an AI optimization and test tuning workflow that integrates with HFSS and third-party network analyzers. Today's presenter is Fan Zhang. He is the VP of Engineering at Acentury Inc. and has been there since the very beginning. He has over 30 years of RF engineering experience and has worked in previous leadership roles at Motorola, Huawei, and Nortel. He specializes in RF test and measurement solutions and has been helping recently and working closely with carrier operators overcome their capacity and coverage issues from 3G, 4G, now 5G. So at this time, I'm going to hand off to Fan, who will take over.
Thank you, David. Let me share my screen. Just 1 second. Let me put a full screen. Good morning, good afternoon, and good evening, everyone. Well, thank you for joining the webinar today. In next 1 hour, I'm going to share our opinions for how 5G in-building and in-building system will be impacted by PIM. Oh, my screen doesn't move. Okay, yeah. First of all, I talk a little bit about the RF solution requirement for the in-building systems. As some of you already know, actually the majority of the voice and the data traffic on the cellular networks happens in building. And usually for this, like in building actually it has high density of the users. So therefore more and more capacity requirement for the in building. These are the capacity requirement. But also at the same time, because of those the LEEDs and the Green Building Initiative, initiatives, like for example, using low E glasses, or actually the refractive and a dense material used by the building. These the typical scenarios like in the basement or the parking lot. And because of these material and well, these stuff are used, and these usually will create a lot of attenuation for the RF signal. And also there's other factor like shadows caused by nearby structures like buildings, hills, and mountains. So all of this actually makes pretty bad coverage for the in-building scenario. Actually got a signal from the outdoor system, outdoor cellular systems. Therefore, the industry, the industry is looking for a proper in-building RF solution to actually get the proper capacity and the good and the data voice and the data services for the in-building scenario. There are actually three major in-building solutions. Well, here shows all the three of them. The first one is the DAS solution, which is the distributed antenna system. So there are two different types of DAS. One is passive DAS, another one is active DAS. So passive DAS is very traditional. It's been in the market for many, many years. Well, with the technology, improved, there are active DAS, which is, it doesn't like, passive DAS using all the passive components using like optical one, convert the signal from RF signal to optic signal. That's actually another solution for is the active DAS. This is the DAS solution. But also recently, because more and more small cell are deployed to the market, and well, technology developed to the small cell, and the small cell has a lot benefit. Well, easy to deploy. I'll talk about in the later slides. But small cell is another solution, and because more small cell deploy and all these benefits small cell system will get, that's why in the market now there's a trend to use small cell, especially a pure small cell in building solution, as the 5G in building solution. But also because both DAS and small cell solutions has its own strengths and weakness. So to get the benefit from both sides, and also a lot traditional in building system are using like either passive or active DAS to get a proper upgrade and share and still reuse the old systems. That's why the market developed the third solution, which we call hybrid. There are two different kind of hybrid solutions. One is the hybrid DAS, which means actually it's the combination of the active and the passive DAS. And another one, another hybrid solution is small cell hybrid, which is the combination of the small cell solution and the passive DAS solutions. So these are three solutions, well, in the market, major solutions for in-building in the market. As I just said, the DAS is very traditional. Then it moved to small cell, and the market trends is for small cell. And considering the benefit for both sides, there's hybrid solutions. Before I get more detail about these solutions, I want to start the poll survey. So I'll give it to David. David, go ahead.
Thank you, Fan. I have launched the poll survey. You should see it on your screen now. Which types of in-building systems have you used? And click all that apply. I'll give the next 20 seconds to receive those results from everybody. And I'll end the poll in about 10 seconds or so. Okay. Fan, there are over 88% of the people have selected both passive and small cells. as the most popular ones, and a couple have picked hybrid active DAS.
Okay, well, thank you, David. Well, it looks, that's, well, we got exactly right topic, because in the later slides, I'm going to talk about it. But let's move to more detail about the three solutions we talk about. First of all, passive DAS. So at right side, you'll see this is actually a kind of configuration of the passive DAS. Maybe most of you guys already know that this is actually basically the carrier or operators. They'll bring actually the eNobi, gNobis inside the building, and then, and bring the RF signal inside the building. This is actually a source signal. Then we're going to use our low PIM combiner or low PIM multiplexer to combine the multiple carrier RF signals or multiple band signals, and then transmit it through the RF coax cable to each floor. Then use those low PIM components like splitter, directional coupler, or tappers to split the power and send them to each individual in-building antennas. It is a distributed, the signal is distributed over a coax cable to each antenna from a single, basic combined signal source. And also because power splitting, so each node or each antenna, actually the power level is very low. It's usually like a 15 to 20 dB maximum. And also another good part for the passive DAS system is if day one, it's designed for the wideband. It covers, like, say, for example, covers all the 5G bands, for example, it's sub 6 gig, all covered. Then in the future, this system, it's very easy to upgrade. Basically, if you want to add any new bands for 5G sub 6 gig, you don't need to touch any of that system. Basically, the passive part, so anything after the combiner, you don't need to touch. You just add more signal source, carrier basically add more radios, for different bands in, then you can use that. Therefore, with this way, actually, there's upgrade, you got a big benefit. And also another big benefit for the cost point of view, it's low maintenance, because most of these components and cables are passive parts, and usually after you deploy, you don't need to really touch it. So there is no or very low actual maintenance cost for the system. Also, another thing is because we just talked about, it's low power for each node, so it will involve actually less interference. So these are all the benefit for the passive DAS system. But on the other side, for passive DAS, there's challenge for the deployment, because for the coax cables and all these components that deploy, it's kind of difficult. The cost is pretty high. And also because coax cables are used for the passive DAS system, that will actually introduce a lot attenuations or insertion loss for the whole systems. So sometimes, for a large building, if you're using very long coax cables, then you may get these kind of RF link budget issue. And third challenge, what we find, for the passive DAS is the PIM, because all these components are PIM source. All these components and cables are PIM source. That's why there is PIM issue. So if you didn't choose the right PIM rejection for all these components or cables, then you may get PIM issue, which actually makes the serious system performance issue. And because of this, then industry developed an active DAS system. Active DAS is very similar to the passive DAS, especially at the source part. So same carrier being the signal source and combine the signal. Then it use the active parts, which is Mars unit and the slave unit. So Mars unit will actually up convert the RF signal to the optical signal, and then transmit the optical signal through either optical fiber cable or Ethernet cable, then to the similar location as these passive DAS, antenna location, to the slave unit, and down convert the optic signal to the RF signal, then transmit through the antenna and proper cover the whole building. So because of using these fiber cables or Ethernet cable to replace the coaxial cable, first of all, there is no like insertion loss for these like optical or Ethernet cables. That's why actually those RF link budget issue is not anymore there. And also the cost of those optical fiber cables or Ethernet cables is way lower than the RF coax cables. So you get a big benefit for actually the upfront capital cost. And if you are using the Ethernet connections for actually to transmit the signal, then another benefit you'll get is you don't need to have the power supply. So basically you can use the power over Ethernet to replace the power supply. Yeah, so for this, the benefit, obviously, it's easy to deploy, significant upfront capital cost benefit, and you don't have link budget issue. And also another big thing is because Ethernet cable and optical cable are used, so these are not PIM source. So any inter-system PIM issues are not anymore there. There is still PIM issue, but most of the PIM for the active DAS are generated by outside, which we usually call external PIM. So there is no or less internal PIM issue. Unless there's actually a slave unit might have some PIM issue, but this is actually the minimum. So these are all the benefit for the active DAS. But on the other side, there's still challenge for active DAS. First of all, because it's the active system. You have the active master unit and the slave unit. So the active DAS vendor, they tend to charge maintenance fee every year. So there's a maintenance challenge for DAS. Another thing also maintenance related, because if you look at this configuration, there are two active parts. One is actually the active, parts from the carrier side. You have eNovi, GNovi, or the signal source, and then another one is the active DAS systems. So sometimes, if troubleshooting all these kind of stuff, well, there will be, because more active systems involved, then it makes things more complicated. These are all the challenge for the maintenance side for the active DAS. And also maintenance, another thing is, or you get so many small like a slave unit for each floor, and these are active parts. It's worn out, or over the years, you may have to replace them. These are all eventually increase the cost. So that's actually the major challenge for the active DAS system. And because of this, so industry, I just talked, industry developed a hybrid system which combines the active and the passive DAS. This one is also, especially when the traditional, like a building, they have actually, the existing building has the passive DAS already, then they want to upgrade. So they actually put these kind of like a active DAS to replace actually the major part to bring the signal to each floor. So here in the left side, you'll see basically after the signal source to combine the signal, they use a active DAS system to bring all the RF signal or up convert the RF signal to the optic signal, and then send it to each floor and down convert it to the RF signal. And then in the floor, they use a passive DAS system, then use actually passive DAS to distribute the signal to each antennas. With this way, basically for the major insertion loss, basically the long coax cable are used between the floors. These are replaced by fiber cables or Ethernet cables. That can, first of all, save the cost. Second of all, actually, it will reduce those I-Flink budget issue. But also on the other side, for each floor, if passive desks are used, then those benefits we just talked about, easy to upgrade, the maintenance cost is lower. These also, you got those benefits. And especially like what I said, the building got, the building got existing passive desks, then to upgrade it, that's actually a hybrid system maybe is the best solution. So with this kind of solution, well, we got a benefit from both worlds. But again, the maintenance challenge is kind of in the middle between, because you got a both benefit, but the upfront cost is a little bit higher, and also the maintenance, because you still have active desk system, so the maintenance cost is also there, and deployment is a little bit higher because you still use the passive desk system for this kind of like a hybrid solution. And now the small cell. So this was I just talked about, because more and more small cell deploys to the market, and especially for 5G, there's a big percentage of the small cell solutions for 5G systems. So now actually a lot of carriers, and well, this is actually the poor actual survey we just also talking, a lot of small cell are used by in-building system, especially for the 5G trends. So the good part for small cell is it's a single vendor. So whatever which systems, the carrier, when they bring it in, so you have the BBU, the baseband unit, basically it sent the baseband signal through, actually the green line is basically the baseband signals. The green line is the optical, well, fiber cables or Ethernet cables. So it goes through there, then to each small cell. And then it radiates with low power for each small cell and proper cover the whole building. Similar to the active desk, this system doesn't have the internal PIM issue. So only the small cell itself, it might have some internal PIM issue. But in general, because all the optical and Ethernet those Ethernet cables, it won't generate the PIM. And also because those cables are easy to be deployed, so the upfront capital cost is quite low. And that's why most people like to use this kind of solution, trying to use for 5G in building systems. But on the other side, it's still there's maintenance and upkeeping challenge for the neutral host. Well, same, because it's all active parts. If you worn out, sometimes they have issues, or with the time going, you may have to replace those parts. So that is actually a maintenance challenge. And also, I don't see a single wideband solution, which means one single small cell can cover all the bands, especially new 5G bands we are talking about, like CBRS, or maybe eventually in the future, the LAA bands. So it's not a cover. So this actually is another challenge. So for the upgrade. And also another thing is also that's actually the major topic I want to talk in my later slides is there are no internal PIM issues. But with today's limitation of the small cell solution and also the way of the deployment, there is external PIM issue, which means PIM generates by outside system. And sometimes that external PIM issue could be very serious. Okay, before I get to the detail about how does PIM impact, the in-building pure small cell systems, which is a 5G in-building systems, I want to go to the second poll survey. So David, please go ahead.
Thank you, Fan. You should see the poll survey now on the Zoom window. Please proceed to provide your answers. The question is, have you ever tried to solve a PIM issue in the field? Just give it 5 more seconds here. "60-40 split. Fan, 60% said no, 40% said yes."
Okay, thanks, David. Yeah, well, it seems PIM, well, still have it. It's an issue, so I don't know what's the detailed system it deploys. So, but in the later slides, maybe I expand. It will be clear, for these people who get a PIM issue, and you'll find maybe some other source of the PIM issue I talk about today. Let's move to next section. Okay, so the PIM issues in 5G systems or the in-building systems. This time I will talk more about those like small cell systems, because that's the market trends. Let's suppose in our building there are 3 carriers try to deploy their system to the same building, and each carrier want to deploy 3 bands. So 3 times 3, then well, like what I said, the small cell now, I don't see a single small cell can cover the whole sub-6 gigs system. So this is actually, that means actually in the same location of the small cell, what the design, location of the antenna site, you will have possibly 9 small cells. Well, even in the future, there is such kind of technology developed, a super wideband small cell solution. So which means each single carrier, you only need to use 1 small cell to cover all the bands. But there will be still 3 small cells at the same location. I think the major reason what I found is, nobody actually want to, well, share the small cell, because nobody wants to give their system to controlled by either their competitor or other people. That's why what I think, in the same location, if you do the small cell solution, then with this kind of scenario, you will have actually between 3 to 9 different small cells. Another thing, to deploy all of these small cells at the same location, the major reason is, first of all, when you're using the in-building design tool to design, if you give the same parameters want to get the proper coverage for the whole building, it tends to actually design it, all the small cells, different band, different carrier in the same location. This also, for the building owner, they get benefit for this, is because all these small cells can share the same optical source or Ethernet source, and also the same power supply. So otherwise, if you separate them apart, then you may have to deploy different, like 9 different optical Ethernet connections to different small cells and provide 9 different power supplies for them. So that increases a lot for the cost, deployment cost. So with this kind of scenario for the small cell deployment, I'm talking about the pure small cell deployment, then there is actually the potential I just talked about, external PIM issue. So first, suppose if you look at the right side, suppose we have 3 small cells. So each small cell itself is a big PIM source, because small cell itself, it has magnetic material inside and diode inside. So when another small cell signal get to this small cell, then it will generate the PIM product, and then radiates through over the air, and the source small cell, when it picks up the signal, when those PIM product is getting to the receive band at the source small cell, then your receive band got polluted. You got interference, those PIM issue, then it will actually impact the performance of the small cell system. This is the one external PIM issue. And the second one is, this is pretty tricky, maybe, actually it has the PIM research result to show this. When a strong signal combined with a weak signal, you may still get a serious PIM issue. This research result were published in the IEEE paper. So I'll have the later slides to talk about details. But this is the kind of scenario, if I show here, is just like, say, you have small cell C. If it transmits a signal over the air directly to small cell A, the signal got a big attenuation over the air. So there's a weak signal of small cell C to get to small cell A. And another path is the small cell signal may get actually refracted by small cell B, then get to small cell A. But both way is kind of like you got a weak small cell C signal get to small cell A. And small cell A itself, a radiated signal, and it's a strong signal. So compared with the signal from small cell C. So at the surface of the small cell A antenna, it's exactly a strong signal combined with a weak signal, which is small cell C. And when actually the third order PIM get to the receive band, that could cause serious PIM issue. And also for these two external PIM issue we just talked about, those two PIM issues are all external PIM issues. So for external PIM issue, it's not easy to measure and it's very hard to reduce. So that's why, well, I was talking about a pure small cell system, you may get a serious PIM, external PIM issue. So we'll talk about a solution later. But let's look at a more detail about the second one, which I just talked about, a strong signal combined with a weak signal, why and how it creates a serious PIM issue. So first of all, I actually put a link here. This is actually the IEEE, this is the research published in the IEEE paper link. So basically, I just talk about, conclusion is a weak signal combined with a strong signal. It will actually cause serious, possibly serious PIM issue. Say if we have two signal, carrier 1 and carrier 2, which is frequency 1, F1 and F2. And then the PIM, third order PIM production is 2F1 minus F2 and 2F2 minus F1. The research result shows the PIM level, third order PIM level at 2F1 minus F2. This is actually a major one we concern about because it's in the lower side. Usually it's in the receive band side. So this PIM level, third order PIM level, it depends on the power of F1. So F1 will be the major impact for the PIM level. When F2 drops, even F2 power is much lower than F1, the PIM product are still there. So it doesn't like most people think I should get equal power of the PIM, equal power of the carrier, then my PIM will get worse. That's incorrect. So with this way, actually the combination way, when the F1 is very high and F2 is worse, especially when F1 is twice power of F2, your PIM get the worst case. So it's not equal power is the worst case. So this is actually the research result we'll get from that actual PIM research and published in the IEEE. And another interesting point, they do, maybe most of you also want to know, is that's another test they did for that PIM research is when they put equal power for F1 and F2, and they change them simultaneously. And they found every dB change between, well, for the carrier 1 and carrier 2 simultaneously, depends on different component. You may see 2 to 2.6 dB PIM changes. This slide shows the detailed test cases did for this PIM research. So the test case one, as I just explained, so what they did is they put F1 and F2, the total power as 40 watts. And they use 3 different components to run a test to measure the PIM. And first one is a coupler. You see the black line is the coupler. And the blue line is the adapter. The green line is the microstrip. And what they did is they changed the power ratio between F2 and F1, and then measure the third order PIM. The result they got here, we just is because all 3 curves are similar. So I'm going to use the coupler as an example. So here for the yellow part, you'll see this one is when F1 is equal power as F2. So your PIM is around -70 dBm. But you see the second one here, the PIM is higher. That's actually when the F1 is twice of F2. So F1 power is double of F2 power. So you see that actually shows the worst case. So it's actually worse than the equal power. And the third one, if you look at it here, is when F1 is 7 times power of F2. Here, it's pretty much like 2 to 3 dB different from between, when both power are same. So this test result tells us, a strong signal combined with a weak signal, it will still generate the PIM issue. It doesn't like, you need to have 2 very strong signal. And the worst case is when one signal power is twice of second signal. So that's exactly the case I expand in my former slides. So when you got a multiple small cell deployed in the field, when they are close enough, so you create these kind of scenario, you make it a strong signal combined with a weak signal, especially a weak signal from external. When that generates the PIM, then these are sort of like external PIM issue. It's very hard to be solved. Then another thing is, this is actually the test that I talked about when they also, for that research, they also did the equal power test. So basically, they actually fixed the power of F1 and F2 and changed the power simultaneously, then measure PIM3. So again, using the same components, it's same trends, you'll see, the black, blue, and green. And then when they measure, they found, here is the result. So for the coupler, it's around a 2 dB change, PIM change for PIM product. It's around 2 dB change when carrier power got 1 dB change. And for other tools, it's like between 2 to 2.6. So that's the result shows in that IEEE paper. So anyhow, these are explained, for this 2 slides I explain, when a strong and a weak signal impact, combined together, how does it create the PIM issue? And this is exactly, for pure small cell, when you deploy multiple small cell, especially for 5G system in the field, these are possibly PIM issue you will get. And now let's talk about a solution. So, the PIM, external PIM impact for the 5G in buildings, that's what we just talked about now. Solution is, because we just talked about these issues are not inter-system issue. It's not generated inside the system, the PIM. So the only way you could do is, first of all, is move antennas. So basically, you keep those antennas in all small cells really far away, and make one weak signal is very, very, very weak. That actually, it won't at your general PIM. But as I just explained, if you make that way, then you may have to add more fiber or Ethernet connections or power supply. That increase the cost. So this is the challenge for this kind of like solution. And the second solution is, this is also our opinion, is use a hybrid small cell system. And basically, we turns external PIM to a controllable internal PIM and use a high PIM rejection component to solve these kind of PIM issues. First of all, make it external to internal. Then we have some way to solve these issues. So here is our suggestion. So at the left side. So basically, bring all the signal to each floor with the small cell. You may get multi-carriers, multi-bands, multiple small cells here. But then after that, you use a combiner. These combiners should be high PIM rejection. We recommend actual low PIM combiners like, well, it's better, the PIM rejection is like the better, well, the lower the better, but it's like in the market, like FC, it's better than minus, or it's minus 165. Well, that should be good. And after that, then you use a passive DAS system with actually a controlled PIM components, and use these passive DAS antennas. So all the RF signals will share a single passive DAS antenna. That won't generate those kind of like external PIM issue, which I just talked about. And with this way, first of all, it's easy to upgrade. When you want to upgrade, add to another band, you just add another small cell and extend the port of your combiner. Just combine the signal to share the same passive DAS system. And for the passive DAS system, if it's wideband, then whatever how many bands you add, it covers those bands. Then you don't need to do anything. So just upgrade to small cell, and all the small cells can share those optical or Ethernet connections or power supply. So this is actually a typical one we suggested, to combine the hybrid small cell solutions, which to avoid the external PIM issue I just explained. Well, again, there is still a challenge for this system. The deployment may be a little bit higher because still there is passive DAS involved. But on the other side, because a lot of buildings now already been covered by the passive DAS systems, especially each floor level, then if that's the scenario, then it'd be much easier to deploy because you just swap the existing whatever is active DAS or it's the passive DAS. Then for the signal from actually the source signal to each floor, you just replace it with a small cell. Then you can still go with these kind of hybrid small cell solution. That actually you can get the best benefit and also avoid the serious PIM, external PIM issues. And well, these are pretty much what I tried to share. What is the possible PIM, especially external PIM issue could impact a pure small cell and the potential future 5G in building systems, and what is the solution. Here let's move to the third poll survey. I give it back to David. Go ahead, David, please.
Thank you, Fan. I've just launched the final poll survey. Are you currently seeing PIM issues when deploying small cells today? We'll give you about 20 seconds. Five more seconds or so. Get as many participants as possible. Okay. So Fan, we have 87% have not deployed a small cells infrastructure yet, but we do have a few people that said yes to this.
Oh, okay.
And a small amount said no, but there was a couple that said no. Sorry, a couple that said yes.
Right. Thanks, David. Yeah, this is actually what I said, eventually in small cell, but yeah. But one thing actually I forgot to mention is these kind of like hybrid small cell solutions has already been used by, I do see few tier 1 operators in North America, they've started to deploy these kind of hybrid small cell systems. I think the major reason is to avoid multiple small cells deployed in the same location and to avoid those kind of external PIM issues. Also, because we are talking about those like PIM issue possibly will impact the small cell and potential 5G in-building solutions. That's why we do recommend it to use our high PIM rejection components to actually prevent the PIM issue. Well, first of all, make the external PIM maybe to the internal PIM, then use the high PIM rejection. So one thing is about us, we do provide actual low PIM component. I think a lot of you may already know. So we are very few component vendor who provides actual low PIM component. So all of our component can be -165, whatever is 7 plexers. We now actually make 7 plexers or a tapper or coupler. So these are our actually pretty unique stuff. So we can provide good components to provide a very high PIM rejection. And also we do supply, our component do supply, public safety, 3G, 4G, 5G network, and all the sub-6 gig bands. It's a wideband solution. So for any 5G bands we support. Okay, so let's move to the Q&A section.
Fan, there is one question, few questions actually. One is the PIM would be present on 5G TDD system?
Yeah, well, 5G actually for the TDD system, because the TX and RF signals are using different time slot. For a single TDD system, usually because they're not simultaneously, so you don't have the PIM issue. But when you have the multiple TDD systems, say you have different TDD systems from different operators, they will not sync up. So there's maybe there's a case, especially these are those stuff I'm talking about external. You got multiple small cell, then you could get these kind of issue because you combine the signal. And also a lot of in-building systems, like even the TDG is like 5G only, but well, even the 5G is TDD system, but your 3G, 4G is the FDD. And your 3G, 4G system, for those kind of scenario which I talk about, either internal PIM or the serious external PIM issue, it causes, I just explained, that will still generate some PIM product which may impact the receive band of the 5G TDD systems. So in other words, yes, you do have a TDD if there's a multiple system deployed in the same location. Or actually, if you have multiple TDD system there, then you still have PIM issue. Okay, so okay, let me move to another question. Okay, here's a question. If we have an existing passive DAS in-building system to be upgraded to 5G system, but the carrier wants to merge it with their small cell solution, do you have any suggestion? That is a good question. Well, first of all, I think you should look at if your passive DAS system is wideband, which means it covers the 5G band you want to upgrade. If it is, then I do suggest maybe you want to actually convince the carriers to just add their signal source to your combiner. You just combine the signal and still reuse your passive DAS systems. And that way, actually, you don't actually your passive DAS, you don't need to do any upgrade. Yeah, this is the way for the existing if it's covered by the passive DAS. But if it's not covered, then maybe there's a good combination where you can bring the small cell for that specific 5G system to the DAS antenna location close. And then you take the small cell signal and combine it with the DAS signal with a combiner. That actually, because it's a low power, you don't need to have a high power, low power and combiner. But still you need to have a high PIM rejection. So low PIM, extra low PIM combiner to combine a signal and share the wideband in-building antenna. And with this way, well, first of all, you combine the existing passive DAS system with the 5G small cell, but also you can avoid these kind of like external PIM issue. Okay. So let me move to let me see any other questions.
If you do have a question, there is a Q&A icon button at the bottom of the Zoom webinar application there.
Yeah.
Feel free to type in there.
Okay. Yeah. Well, and there's another question just pop up. Okay. For 5G, high frequency band like CBRS or AAA band, the insertion loss through the coax cable is huge. While developing a passive DAS or hybrid building system, how to avoid high insertion loss issues? Well, this is a very good question. Actually, I did discuss this with some of our customer as well, because recently, actually, for North American market, a lot of C-band or CBR band in Canada are involved. All the operators might think to actually deploy these systems. But if it goes through the passive DAS system, then there are a lot insertion loss. It costs. Sometimes the link budget has some issue. Then it makes the different coverage for the in-building scenario. So because the power level are different for between this, these like a C-band or the regular, like the lower frequency band systems. Yeah, from our point, like from my point of view, if it is, say, if you have enough link budget, then I still suggest to combine that CBR band with other small cell signal, then use a passive DAS. So a similar structure as I just explained, for the hybrid small cell system. If there is actually link budget issue, then my recommendation is maybe you can use the same way as I just suggested. Say you actually deploy that small cell close to the passive DAS, well, a hybrid passive DAS system, and then take the signal from the small cell, combine it with the DAS signal and share with the same wideband antenna. Again, with that way, you don't have link budget issue. You can do whatever, so keep the same power, keep the same coverage for the different bands, 5G, 3G, 4G. So to get the whole building proper covered by all the bands, but also at the same time, you can avoid those external PIM issue I'm talking about. So, but again, you need to use all the extra low PIM component to avoid this kind of issue. Okay, let me see any other questions.
You have about 3 minutes. If there is a quick one you can answer, do so. If not, we can close the session as well. There is a question here about the presentation. Yes, if it's being recorded, it is recorded, yes, and it will be shared to all registrants. So you will see that, yes.
Oh, okay, sorry. That's why I didn't see the question in the Q&A. I saw it now. I saw it in the chart.
Yeah, that's okay.
Yeah.
I think with that, if there are no further questions, we will close the webinar session now. If there are any other further questions after, feel free to contact us here at info@acentury.ca. Website is www.acentury.ca. Thank you again, everyone, for your time. Appreciate you spending time with us. And thank you, Fan.
Thanks, everyone.